Hello everyone, okay, Mr. Chong here. We are looking at 9.2 now, just continuation of what we learned in 9.1. There are more things to take note of here because I prepared the question in a way that given you the common type of questions that you may face in your assessment. Alright, so let's get started. Now, firstly, we look at the first question. We have silver chloride, right? And if you were to already understand your flowchart, how to choose a preparation method, right? You ask yourself the first question, and you would then know that it is insoluble. Secondly, there's no second already, right? Because insoluble here meaning precipitation method. Okay, hence precipitation method we are mixing this solution and this solution, right? Because remember precipitation method we are looking at two solutions add together will give you an insoluble precipitate, and that's what we're going to do here. Okay, so hence the name of this method we are going to know that it's precipitation. Very clearly we know that X. We move to the reaction equation. We're using two solutions here to form a solid here. Okay, so one thing you should know is that Ag ion is plus, is a fixed charge, although silver is in the transition metal block. Okay, so many of you, when I marked your papers, you were writing a 2 plus charge for the silver ion, and that's incorrect. Right, so once you know the charge, barium is a group 2 element, it's the Ba2 plus, and everything else will fall in place. Then you just need to balance it. Okay, so balancing equation and chemical symbols and chemical formula is revised on it. Okay, now next, they ask you, right, how a pure dry sample of silver chloride can be obtained from the reaction mixture. Okay, now reaction mixture here means already reacted or mixed together. So sometimes, right, the question asks you in this way because they don't want you to write so much to answer. Okay, I've seen many of the answers and you have started from step 1 all the way to drying the precipitate. So here in this case, you must know that they're saying, oh, it's already reacted. And so from this mixture of solid and solution, how are you going to obtain pure dry sample of this? Okay, taking note it's already reacted. Hence the answer is as simple as this, right? Here, you start with filtration, okay, then wash with distilled water. Many of you did not write this part, wash with what? Distilled water, not with any water. It must be distilled water. Distilled water contains no other ions. So it's just water. And you don't want to introduce any other impurities onto the whatever you're washing, right? So you just use distilled water. Water from the tap will contain ions, and that will contaminate whatever you are washing. Next, dry between filter paper. Many of you missed out this part. So just say dry with towel, dry with your shirt, dry with what? Okay, so it's very common last 3 steps, right? Filter, wash with distilled water, dry with filter paper. Okay, so in this case, already mixed. So take note, that's what the question requires you to say, issue captioning. If they didn't say already mixed, right, they just say how you obtain this thing from 2 reactors, for example, then you must be from step 1, mix substance A into excess of substance B, stir until no more precipitate form, then you start with the filter, wash and dry. Okay? Okay, now let's move on to question 2. Question 2, we are preparing sodium chloride crystals. And first question we ask ourselves already, we know that it's soluble. And we move on to the next question, we know that this is a group 1 metal. And so this must be prepared by titration method. Okay, always you must come out with the method in a few seconds. Then after that, you must come with the suitable reactions almost immediately. Right? So here's the suitable reactants here. They're using sodium hydroxide with a suitable acid. Right? And you already know which acid to use, right? Because you know that chloride ion comes from hydrochloric acid. Okay? So they show you the first 3 steps. You measure out, you're going to add indicator, you come back to this indicator later, and then you're going to add the acid slowly until it turns orange permanently. This is what we call the endpoint. and we record the volume. Okay, this first three steps. Part A, we know already, titration, acid is hydrochloric acid. Part B, apparatus A and B. Now, many of you didn't get this right. You see, measuring 25 cm cube of solution using A. Now, this is a exact volume. And if you have learned in your titration practice the other time, if you want to measure exact volume, we use an apparatus that only has one exact volume to be measured. For example, the pipette that we used previously was a 25.0 cm cube pipette. Okay, so here apparatus A is actually your pipette. Then you will fill your burette with the acid and slowly add it into the conical flask. Okay, so don't get confused. You never use measuring cylinder. You never use a dropper. Some use a dropper. You will use a conical flask or beaker to measure volume. So measuring a fixed and exact volume, just one volume, we use this apparatus or pipette in this case. Okay, so part C, how you obtain pure and dry sample from the method above. And obviously the method above already gave you 3 steps. So you need to continue on the first 3 steps. Okay, some of you did not realize this. You just went on and write a lot, the whole paragraph of first 3 steps and then what's happening next. Okay, I mean that's better than the other group of you, which is you didn't realize that these first 3 steps had this inside. Okay, so with this indicator in your solution, you cannot go on and heat the filtrate until saturation, because then it will contain this and this will be a contamination. Right? If you're going to have metal orange there, right, your crystal will come out to be orange. It won't be pure. Right? So you must take note of this. There's a reason why in the textbook you also mentioned, right? Once you have recorded the volume of the acid, you need to repeat the experiment again without the indicator before you continue doing other things, because now you already have the volume of the acid used, so you can just repeat without the indicator needed really. And so that is what you're going to do here. So you're going to repeat the experiment again. You're going to mix this, okay, with the volume of hydrochloric acid from step 3. Take note, no indicator used here, because we don't want the crystals to be contaminated. We already know the volume that we are using. So after this step, then you're going to be pouring it into the evaporating dish and heat until saturated solution is okay. You already know why saturated needed, right? So you're going to leave some water behind. And so when you allow it to cool, the water will form crystals of the salt. Once you have crystals there, you're going to filter, okay? Filter first, obtain the crystals, then you're going to wash with distilled water and dry with a few sheets of paper. Okay? Now, this word here, little, is good to use in this case because you are forming soluble salt. So, you want to avoid dissolving the salt if you are going to use too much distilled water. Okay, so it's really just for you to note. Okay, so it's good to have this little here in all your methods. Okay, you can write little distilled water for classification method as well, just to be safe. Okay, I don't know whether the questions will come out and ask you, why do we use just a little distilled water? The answer is actually to avoid dissolving the salt, because you are forming an insoluble salt here. Okay, so take note for this. For titration, usually they won't ask you to write the whole thing. If they ask you to write part of it, make sure you have a repeat experiment with no indicator used. Okay, because you want your crystals to be contaminated after they are formed. Then you continue to heat until saturated, allow to cool, filter, wash, and dry. So that's for titration. Okay, that's for question 2. Okay, now we move on to question 3. Question 3, we are forming ammonium chloride. So, as always, firstly, it's soluble. All ammonium salts are soluble. And secondly, it is a NH4 plus salt. Considering all this, I need to use titration method. Okay, but here, we are not using titration method, right? Because we are actually having a solid ammonium chloride here. Ammonium carbonate here. Okay, and we're adding ammonium carbonate to magnesium chloride solution, and the reaction mixture was filtered to obtain a precipitate. So there is precipitate form. Okay, so question is, it cannot be your ammonium chloride because it's soluble salt. And so, obviously, precipitate was not ammonium chloride. So in this case, here you think about it, if you are forming a precipitate, then obviously it will be precipitation method. Okay, and precipitation method says that you need to have two soluble reactants and form an insoluble salt. Okay, so in this case, one of your solution is actually your magnesium chloride solution, right? So one of it is NGCl, but the other one is actually a solid ammonium carbonate. You may be wondering where then is the other solution here. So you can see that I'm using solid ammonium carbonate here. But I know that ammonium carbonate is actually soluble as well. All ammonium salts are soluble. So here, can you imagine I have magnesium chloride solution, and solution we know is magnesium chloride dissolved in water. So when we add solid magnesium carbonate into the solution, it will actually dissolve to form a solution. Right, the water comes from the magnesium chloride solution. So first it dissolved to form the solution where the NH4 plus ion and the CO3 2 minus ion is in the solution now. My NgCl2 solution has Ng2 plus and Cl minus ions coming out from it. So I am just going to focus on the ions here because in precipitation method I want to see whether any of these ions will form a pair that will give me an insoluble substance. To study them, I have found a pair to be my magnesium and my carbonate, because magnesium carbonate is actually insoluble. So the precipitate here is actually my magnesium carbonate. So it's not actually the ammonium chloride pair that will come out as a solid, but it is the magnesium and the carbonate pair that is your precipitate here. Why could it not be ammonium chloride? Very easy to answer this. You just say NH4Cl is a soluble salt, right? Soluble salt, and it will not form your insoluble precipitate. Okay, so we suggest the name of the correct method which we have done so far. We know there is titration and the reagents needed. So here, reagents needed, I can use my ammonium carbonate, right? NH4CO to CO3 ammonium carbonate, which is a soluble carbonate. But I also need my acid here. Okay, so I have a soluble carbonate, ammonium carbonate, and acid here, which acid I use will depend on what salt I want to form. Here I want to form a chloride salt, so I will use the hydrochloric acid here. Simple as that. Once you know the method, you know what salt you want to form, you can divide the reagents. Okay, part C, I want to prepare silver chloride solution. Okay, and silver chloride, we know that it is insoluble. And in precipitation, we are mixing solutions of ammonium chloride and silver nitrate. So these two are my solutions. So hence, we can prepare silver chloride using this method. So hence, the difference in the method of preparing silver chloride and ammonium chloride is very straightforward. Silver chloride, I'm using my precipitation method, right? So AgCl. I'm using precipitation method because it is insoluble, whereas for NH4Cl, I'm using titration method because it's a soluble. That's the main difference between the two salts here. Okay, so this is quite a straightforward question, just asking you about some basic understanding. If not, it should be doable. Okay, now we move on to question 4, which is on lead salts here. I've marked this question. I think there's some confusion that maybe it will have been clarified along the way throughout this video, but let's just focus on elaborating it in this question. So we are given some solubility of some salts here, and we notice that only lead-2 nitrate is soluble. Okay, and so we want to prepare lead-2 chloride starting from this. So you must starting from this means this is your starting reactant. You cannot use any other reactants. You cannot say I want to start from lead-2 nitrate or lead-2 oxide, chloride. You must start from lead-2 oxide and you must form lead-2 chloride. So we also know lead-2 chloride is insoluble and it must be done with precipitation method where you mix two solutions. Okay, so here, many of you are jumping the gun, so to put it. Right away, you saw, lead-2 oxide, I need to prepare lead-2 chloride. I'll just, add to acid, right? Lead-2 oxide is a base, plus acid will give me lead-2 chloride straight away. Okay, so here, when we have insoluble salt being formed, we need to use an insoluble starting reactant. So I don't know whether you realize that here, these two, they don't match anymore, right? We need to use two solutions to form lead-2 chloride, but we are given one insoluble starting reactant. So you cannot just simply add this oxide to an acid and say I can form my lead-2 chloride because it does not match what we need for the method anymore. Okay, why this is not able to do for this method? Simply because of this idea again, right? If we are going to use any solid, in this case, let's say we use lead-2 oxide here, right? It's going to end up the same thing. The layer of insoluble reactant, insoluble salt form, will prevent any reaction from going through here, right? So you will not have a good yield. Your reaction will stop abruptly after a while, and it's not feasible for the precipitation method, or rather forming insoluble salt. So here we need to understand we are given something that is not suitable for the precipitation method. So we must still start from this reactant and create something that is soluble for our precipitation method. And from this table here, the only soluble salt that is mentioned here is your lead-2 nitrate. And so this must be one of your starting reactant here. Right? You cannot use any insoluble stuff, so you can only use a solution, which in this case must be lead-2 nitrate. So then your question should be, how then do I start with this and form this before I can form my lead-2 chloride? Okay, so many of you did not think about this front part. You just went straight to add lead-2 oxide to your acid. Okay, so how do you change this to lead-2 nitrate? Basically, you're going to react this with nitric acid, right? Remember, we are going to use an excess. This is my excess insoluble reactant method because we want to form lead-2 nitrate. Lead-2 nitrate is a soluble salt and it is not group 1 or ammonium salt. So we use this method and we can get our lead-2 nitrate and we can then add our acid, right, to the solution of lead-2 nitrate. Here we are using two solutions and we can form precipitation now. Right, so it's this type of question is very common, right? We are just going to throw you a starting reactant that's not suitable for that method, and then we can see whether you blindly follow what be thrown you, or you think critically about how to get the starting reactants that you need or is suitable for that reaction. Okay, so that's mainly for this question, what you need to note. Alright, then you end off with filter. Okay, to obtain this, wash with distilled water and dry with filter paper. Usual 3 ending steps. Okay, the next question is also similar, right? You see, we have reacted calcium carbonate with dilute sulfuric acid, and we actually want to form our calcium sulfate. Calcium sulfate is insoluble, and we need to use precipitation method with 2 solutions. But here, our calcium carbonate is actually insoluble. So the starting reactants don't match our method in this case, and we need to then change our starting reactant, change it in a reaction to another suitable reactant, and we can start from there. So in this case, we need to change it to calcium nitrate first. And similar to the previous question, we will then react calcium carbonate with calcium nitrate first, right? Because calcium nitrate with nitric acid first. That will give me calcium nitrate plus water plus carbon dioxide. And then we have this, which is our soluble salt. Then we can proceed with the precipitation method that is needed here. Okay, so in this question, they also ask about, why is there a low yield of calcium sulfate? And we have talked about this. There's going to be a layer of calcium sulfate formed around my solid reactant because it's a wrong method for producing calcium sulfate. And it prevents my calcium carbonate from reacting any further. Okay, so how can we tweak this reaction? Is basically to change the starting reactant. We don't use calcium carbonate as starting reactant. If we can just start with calcium nitrate. But if we don't have calcium nitrate, we have nitric acid on hand. We can just react calcium carbonate with nitric acid first, get some calcium nitrate solution, then we proceed to the precipitation method. Okay, so I hope you get an understanding of what salts is about. It's just the 3 methods with some unique situations where it's going to get a little tricky. And so these are the things that usually comes out. So in these worksheets, I drew attention to them, and hopefully you'll be more mindful of them next time. Right, but of course your basics needs to be there. Basic for acid and bases and your foundation for your salts. You need to know the solubility by heart. You need to know the flow chart by heart, which is essentially based on the 2 questions. Whether soluble salt or not. And if yes, it's a cation group 1 or ammonium. Okay, so that's all for 9.2 as well. I hope that's sufficient enough for you to feel prepared for this chapter. And see you in the next one.